The H-class was a series of battleship designs for Nazi Germany's Kriegsmarine, intended to fulfill the requirements of Plan Z in the late 1930s and early 1940s. The first variation, H-39, called for 6 ships to be built, essentially as enlarged Bismarck-class battleships with 40.6 cm guns. The H-41 design improved the H-39 ship with still larger main guns, with 842 cm weapons. 2 subsequent plans, H-42 and H-43, increased the main battery yet again, with 48 cm pieces, and the enormous H-44 design ultimately resulted with 50.8 cm guns. The ships ranged in size from the H-39, which was 277.8 am long on a displacement of 56,444 at, to the H-44, at 345 am on a displacement of 131,000 at. Most of the designs had a top speed in excess of 30 knots. Due to the outbreak of World War II in September 1939, none of the ships were ever built. Only the first 2 of the H-39 ships were laid down. What work that had been accomplished was halted. The assembled steel remained on the slipway until November 1941, when the Oberkommando der Marine ordered it be scrapped for other purposes. Contracts for the other 4 H-39 type ships had been awarded, but no work was begun on any of them before they were cancelled. None of the subsequent designs progressed further than planning stages. Initial design: the earliest design studies for Schlachtschiff H date to 1935, and were near repeats of the early designs for the Bismarck-class ships, armed with 35 cm guns. Intelligence indicating that the Soviet Navy was planning the Sovietsky Soyuz class with 38 cm guns prompted the Germans to increase the caliber of the ship's armament to 38 cm as well on October 5, 1936. The Oberkommando der Marine issued staff requirements at the end of October for a ship of 35,000 long tons armed with 8 38 cm guns with a speed of 30 knots. The ship's radius of action was to be at least equal that of the Deutschland-class cruisers. Design work on the ship that came to be designated H-39 began in 1937. The design staff was instructed to improve upon the design for the preceding Bismarck-class. One of the requirements was a larger caliber main battery to match any battleship built by a potential adversary. It appeared that Japan would not ratify the Second London Naval Treaty, which would bring an escalator clause that permitted signatories to arm battleships with guns of up to 40.6 cm caliber. By virtue of the Anglo-German Naval Agreement, signed in 1935, Germany was considered to be a party to the other international naval arms limitation treaties. In April, Japan refused to sign the treaty. Shortly thereafter, the United States Navy announced it would arm the new North Carolina-class battleships with 40.6 cm guns. Admiral Werner Fuchs, responsible for the staff section in the OKM that determined the operating requirements for the ship, discussed the vessel's design with Adolf Hitler, the leader of Germany. Hitler demanded guns larger than any possible adversary, but guns of the caliber demanded by Hitler would have required displacements of over 80,000 long tons and drafts so deep as to prevent the use of Germany's ports without significant dredging. Fuchs eventually convinced Hitler that the 40.6 cm gun was the optimal choice for the H-39 design. In 1938, the OKM developed Plan Z, the projected construction program for the German Navy. A force of 6 H-39-class battleships was the centerpiece of the fleet. Plan Z was finalized by January 1939, when Admiral Erich Roeder, the commander of the Kriegsmarine, presented it to Hitler. He approved the plan on January 18 and granted the Kriegsmarine unlimited power to bring the construction program to fruition. Only 4 shipyards in Germany had slipways large enough to build the 6 new battleships. The OKM issued orders for construction of the first 2 ships, H and J, on April 14, 1939. The contracts for the other 4 ships, K, L, M, and N, followed on May 25. The keels for the first 2 ships were laid at the Blochmann and Voss dockyard in Hamburg and the Dieskamag shipyard in Bremen on July 15 and September 1, 1939, respectively. The outbreak of war in September 1939 interrupted the construction of the ships. Work on the first two was suspended and the other four were not laid down, as it was believed they would not be finished before the war was over. The keel for H had 880 of steel installed, 3,580 of steel had been machined, out of 5,880 of steel supplied to Blochmann and Voss by that point. Only 40 of steel had been worked into the keel for J, out of 3,531 of steel delivered. Steel for the other four ships had been ordered and partially machined for installation, though no assembly work had begun. It was expected to resume work on the ships after a German victory in the war. The ships neither received names nor were official name proposals published. The names, which appear in several publications, are pure speculation. Especially the often mentioned Graueutschland is highly unlikely, as Hitler always feared the loss of a vessel with name of Germany. The only hint on the names of the units were given by Hitler himself, who mentioned during documented unofficial talks, that he would propose the names Ulrich von Hutten and Gar Paragraph TZ von Berlichingen for the ships, as these names are not connected with persons of the Third Reich or the country itself, so the loss would not have a significant negative psychological and propaganda effect on the German people. H-39 specifications, characteristics and machinery. As finalized, the H-39 design called for a ship 266 am long at the waterline and 277.8 am long overall. The beam was to have been 37 am with a design draft of 10 am. At standard displacement, which was 52,600 long tons, the draft was slightly under the limit, at 9.6 am. With the ship fully loaded, at 62,600 long tons, draft rose significantly, to 11.2 am. The hull was constructed from transverse and longitudinal steel frames and featured over 90% welding. The hull contained 21 large watertight compartments and a double bottom that extended for 89% of the length of the keel. 4 bilge keels were fitted to improve stability. The ships had an estimated complement of 2,600 officers and enlisted men. The ships were to be powered by 12 MAN 9-cylinder double-acting two-stroke diesel engines. The engines were arranged in groups of 4, on 3 shafts, and drove 3-bladed screws 4.8 am in diameter. 4 auxiliary boilers were installed to provide backup power. 2 were oil-fired and were located between the central transmission rooms. The other 2, a pair of exhaust gas boilers, were placed above them. The power plant was rated at 165,000 shaft horsepower and 260 lpm. It provided a top speed of 30 knots as designed. The vessels could have carried up to 8,780 of diesel oil, which enabled a range of 7,000 nautical miles at 28 kn, or 19,200 mi at a cruising speed of 19 kn. Armament. The main armament was to consist of 8 40.6 ACM SKC/34 guns in 4 twin-gun turrets. The 40.6 ACM gun was 50 calibers long and fired at a muzzle velocity of 810 meters per second. The guns were supplied with a total of 960 rounds of ammunition or 120 shells per gun. Each shell weighed 1,030 kg. The guns used a sliding breech block, as was typical for German naval guns of the period. The breech was fully sealed with a 91 kg brass cartridge that contained the 128 kg main propellant charge. A forecharge weighing 134 kg supplemented the main charge. The turrets allowed for elevation to 30 degrees, which provided a maximum range of approximately 36,400 am. Rate of fire was expected to be 2 rounds per minute per gun. Fire control radar was unspecified, but the ships, which were to have been completed by 1944, presumably would have been equipped with an arrangement similar to that of Tirpitz as she was outfitted in 1943-44. Several of the 40.6 ACM guns were constructed before work on the ships was halted. These were later employed as coastal guns, including at Battery Line de Man in France. 12 15 ACML/55 C-28 guns mounted in 6 twin turrets comprised the ship's secondary battery. These were the same secondaries employed on the Scharnhorst and Bismarck-classes. The turrets allowed 40 degrees of elevation and had a maximum range of 23,000 am. They fired a 45.3 kg shell at a muzzle velocity of 875 ams, and were primarily intended for defense against surface threats. The ships were also to be armed with 6 53.3 cm torpedo tubes, all submerged. They were all mounted in the bow, diverging from the centerline by 10 degrees. 16 dual-mounted 10.5 cm/65 C-33 flak guns provided long-range defense against aircraft. Unlike those mounted on the Scharnhorst and Bismarck classes, these guns were armored to protect their crews from shrapnel, debris, and strafing attacks. The new turrets also provided faster rates of training and elevation as compared to the earlier open mounts. Close-range air defense was provided by a battery of 16 3.7 cm/83 C-33 and 24 cm C-38 guns. The 3.7 cm guns were placed in 8 twin mounts while the 2 cm guns were arrayed in 6 Flak-Vierling quadruple mountings. The 3.7 cm guns were closely grouped amidships and had a single, common ammunition hoist. Historians William Dulin and Robert Gask note that the anti-aircraft battery as designed was too weak to effectively defend against the high-performance aircraft that came into service in the late 1930s and 1940s, and speculate that it would have been augmented before the ships were completed. Armor: the design team envisioned the H-class ships fighting at relatively close range, and therefore selected the armor system that had been used by German battleship constructors since the Nassau class of 1907. The side belt was vertical and was attached directly to the side of the hull, in contrast with the inclined armor belt placed inboard of the side wall used by American and French designers. The side belt, which consisted of crop-cemented steel armor, was 300 ohm thick in the central section that covered the ammunition magazines and machinery spaces. The belt was reduced to 220 ohm on either end of the main section. The stern and bow were unprotected by the main belt. The upper side belt was 145 ohm thick. The German Navy did not preserve official estimates for the immunity zone, though Gask and Dulin created an estimate based on the performance of the US 16 and 45 caliber gun firing a 1016 kg shell. The ship's main armor would have rendered them proof against the 16-inch shell at ranges between 11,000 to 21,000 am. The 16-inch shell could penetrate the upper side belt at any range, however, which left the ships exposed above the waterline. The underwater protection system was broadly similar to the system employed on the Bismarck-class. A 45 ohm thick torpedo bulkhead composed of Votan wedge steel backed the side armor and provided defense against underwater weapons. The bulkhead was placed 5.5 am from the side of the hull, though abreast of the turrets and further in the bow and stern. This distance could not be maintained. The distance between the bulkhead and the side of the ship was reduced to 3.25 am in these areas. The designers compensated for the reduced space by increasing the thickness of the bulkhead to 60 ohm in these areas. 2 armor decks composed of Votan hard steel protected the ships from plunging fire and aerial weapons. The upper deck was 80 ohm thick above the magazines and 50 ohm over the machinery spaces. The main armor deck was 120 ohm and 100 ohm thick, respectively, though on the outboard sloped sections, thickness was increased to augment the protection over the ship's vitals. Over the magazines, the sloped armor was 150 ohm thick. Over the machinery spaces it was 120 ohm thick. Concerned with the fate of the battlecruiser La 1 caught at Zoo at the Battle of Jutland, the designers opted to provide relatively heavy bow armor for the H-class ships. A 60 to 150 ohm thick splinter belt protected the bow from shell fragments. It was reasoned that direct shell hits would cause localized damage that could be better isolated than damage from splinters, which could cause extensive flooding. The main battery gun turrets were armored with 385 ohm thick faces, 240 ohm thick sides, and 130 ohm roofs. The rear side of the turret was 325 ohm thick. In addition to the protection offered by the greater thickness, it also moved the center of gravity of the mounting to the rear, which helped balance the turret and improve its operation. The barbets upon which the turrets sat were armored with 365 mm face-hardened steel above the upper armor deck and 240 mm non-cemented steel below the deck. The 15 cm gun turrets had 100 mm thick faces, 40 mm thick sides, and 35 mm thick roofs. Their barbets had 80 mm thick armor protection. The 10.5 cm mounts were protected by 20 mm thick gun shields. The forward conning tower had 350 mm thick sides composed of KCA and 200 mm thick roof composed of non-cemented steel. The rear conning tower had 100 mm thick sides and roof, KCA and non-cemented steel, respectively. Design escalation. In early July 1940, Hitler ordered the Navy to examine new battleship designs and how wartime experience might be incorporated. A study was completed on July 15, and contained several recommendations for the H-class ships, including increasing the freeboard and strengthening the horizontal protection. In order to maintain displacement and speed and accommodate the increased weight of the additional armor protection, the design staff drew up an informal design, known as Scheme A. The design removed one of the main battery turrets to save weight. The propulsion system was also increased in power to keep the same speed as the original design. The original diesel-only system was replaced by a hybrid diesel and steam turbine arrangement. The staff also prepared a second design, Scheme B, which retained the fourth turret and accepted a much higher displacement. This design also incorporated the mixed propulsion system. These studies were abandoned in 1941 after Hitler decided to halt further battleship construction until after the end of the war. The design staff therefore attempted to improve the armor protection for the H-class. The 1940 designs did not form part of the design chain that resulted in the H-41 through H-44 designs. H-41, bomb damage sustained by Scarnist in July 1941 provided the impetus for the effort to increase the horizontal protection for the H-class. The designers were confronted with a significant problem. Any increase in armor could correspondingly increase the displacement and, more importantly, the draft. It was necessary to maintain the full load draft of 11.5 am of the H-39 design for operations in the relatively shallow North Sea. The only option that allowed the displacement to be maintained while armor thicknesses to be increased was to reduce the ship's fuel supplies. A 25% cut in range was required, which was deemed unacceptable by the OKM. It was eventually determined that since deep-water anchorages on the Atlantic coast were available, it would be permissible to allow the draft to increase. The initial redesign called for an increase of only 5,000 long tons, 40% of which was additional deck armor, the remainder being used for a larger caliber main battery. One of the most significant changes was the decision to bore out the oversized 40.6 cm guns to 42 cm caliber for the H-41 design. The design staff determined that modifications to the ammunition hoists and loading equipment would be easily effected and that the original turrets could be retained. The OKM was aware that the British had settled on a 40.6 cm gun for the proposed Lionel class. The 42 cm gun would grant the H-41 design a significant advantage over these new adversaries. The ship's armament was otherwise unchanged, apart from an increased number of 2 cm anti-aircraft guns, of which there were now to be 34. The ship's main armor decks were substantially strengthened, the deck was increased in thickness from 120 mm to 200 mm and the sloped armor at the edges was thickened from 150 mm to 175 mm. Wartime experience with the Scarnist class indicated that the torpedo defense system was insufficiently strong to protect the H-39 design from underwater damage. Beam was therefore increased, with greater width added at the ends of the armored citadel to allow a greater distance between the side wall and the torpedo bulkhead. The stern section of the torpedo bulkhead was also strengthened structurally to allow it to better contain the force of an underwater explosion. A triple bottom was also included in the design, the first time a feature was used in a German warship design. The loss of Bismarck in May 1941 also influenced the design. 2 large skegs were added to the outboard shafts to protect them and increase support for the stern while in dry dock. The rudder system was also designed with an explosive charge to detach the rudders in the event they became jammed. The finalized design was approved by Admiral Rohreder on November 15, 1941. The new design measured 282 am long at the waterline, had a beam of 39 am, and a draft of up to 12.2 am at full load. The increase in weight, while engine power remained constant, reduced speed to 28.8 kN. The OKM planned to begin construction 6 to 9 months after demobilization, initially at Blochmann-Voss and the Deutsche Werke shipyard in Kiel. Die Skimag, which had been awarded the contract for J, could no longer be used due to the increase in draft, which precluded travel through the shallow Weser. Following the completion of a new, larger dock at the Kriegsmarine in Wilhelmshaven, work would also be done there. The increased size of the ships would have lengthened the building time from 4 to 5 years. H-42 through H-44. On February 8, 1942, Albert Speer became the Reichsminister for Armaments and Munitions and gained influence over the Navy's construction programs. Speer reassigned some members of the H-class design staff to work on new U-boats and other tasks deemed critical to the war effort. The Schiffsneubau Commission, intended to liaise with Speer and the OKM, was created and placed under the direction of Admiral Karl Topp. This group was responsible for the design work that resulted in the H-42 type, as well as the subsequent designs. The construction office of the OKM formally concluded their work on new battleships with the H-41 type and played no further role in battleship development. After the completion of the H-41 design, Hitler issued a request for a larger battleship and placed no restrictions on gun caliber or displacement. The only requirements were a speed of 30 kN, horizontal and underwater protection sufficiently strong enough to protect the vessel from all attacks, and a main battery properly balanced with the size of the ship. The results were purely study projects intended to determine the size of a ship with strong enough armor to counter the rapidly increasing power of bombs deployed by the Allies during the war. The Commission did not discuss its activities with Rohreder or his successor, Admiral Karl Dar Nitz, or with other branches in the OKM. As the designs for the H-42, H-43, and H-44 battleships were purely conjectural, no actual work was begun. The German Navy did not seriously consider construction on any of the designs, which were so large that they could not have been built in a traditional slip way. Indeed, the construction office of the OKM sought to disassociate itself from the projects, which they found to be of doubtful merit and unnecessary for German victory. The first design, H-42, was 305 am long between perpendiculars and had a beam of 42.8 am and a draft of 11.8 am designed and 12.7 am at full load. The design displacement was 90,080 and at full load rose to 96,555 long tons. The dimensions for the second, H-43, increased to 330 am between perpendiculars, a beam of 48 am, and design and full load drafts of 12 am and 12.9 am, respectively. Design displacement was 111,080 and estimated at 118,110 long tons at full load. For the final design, H-44, the length rose to 345 am between perpendiculars, the beam increased to 51.5 am, and draft rose to 12.7 am as designed and 13.5 am at full load. The displacement for H-44 was 131,080 as designed and up to 139,272 long tons at full load. Details on the propulsion systems for these designs are fragmentary and in some cases contradictory. Eric Grau paragraph near notes that some had pure diesel engine propulsion, others had hybrid engine turbine propulsion systems, but does not record the type and performance for these propulsion systems. William Garsk and Robert Dulin state that all three designs featured hybrid diesel steam turbine plants, each supplying 266,000 shp for top speeds of 31.9 kN, 30.9 kN, and 29.8 kN for H-42, H-43, and H-44, respectively. According to Garsk and Dulin, the designs had a speed of 24 kN, 23 kN, and 22.5 kN, respectively, on just diesel engine power. Both sources agree on a maximum range of 20,000 and a cruising speed of 19 kN. Information on the armament outfits for the designs is equally contradictory. Both sources agree on the armament for H-44, which was to have been 850.8 cm guns. Paragraph NER indicates that H-42 and H-43 were to be armed with 848 cm guns, while Dulin state that the H-42 design was to have retained the 42 cm guns from the H-41 design, and H-43 would have also been armed with 50.8 cm pieces. Both works agree that the secondary armament was to have consisted of 12 15 cm/55 guns and 16 10.5 cm/65 guns as in the previous designs, though the lighter weapons are disputed. Paragraph NER states that all three designs were to be equipped with 28 3.7 cm and 42 cm anti-aircraft guns, while Dulin report only 16 3.7 cm guns and 42 cm guns for H-43 and H-44 only. H-42 was to have 24 cm guns. Both sources concur that 6 submerged 53.3 cm torpedo tubes were included in each design. Designs, Notes. Footnotes. Citations. References, Breyer, Siegfried. Battleships and Battlecruisers 1905–1970. Garden City, New York, Doubleday and Company. ISBN A978-0-385-07247-2. Breyer, Siegfried. The German Battleship Skynest. Westchester, Pennsylvania, Schiffer Publishing. ISBN A978-0-88740-291-3. Campbell, John. Naval Weapons of World War II. London, Conway Maritime Press. ISBN A978-0-87021-459-2. Gardner, Robert. Chesno, Roger, eds. Conway's All the World's Fighting Ships, 1922–1946. Annapolis, Naval Institute Press. ISBN A978-0-87021-913-9. Gask, William H. Dulin, Robert O. Battleships, Axis and Neutral Battleships in World War II. Annapolis, Naval Institute Press. ISBN A978-0-87021-101-0. Paragraph NER, Eric. German Warships, 1815–1945. Annapolis, Naval Institute Press. ISBN A978-0-87021-790-6. Jochman, Werner, ed. Adolf Hitler. Monologe im Fahr-1-Quarter Hauptquartier 1941–1944. Hamburg, Albrecht Naus. OCLCA 600,768,897. Maiolo, Joseph. The Royal Navy in Nazi Germany, 1933. €39. A Study in Appeasement and the Origins of the Second World War. London, Macmillan Press. ISBN A978-0-312-21456-2. Picker, Henry. Hitler's Geschichtssprache im Fahr-1-Quarter Hauptquartier. Stuttgart, Seaworld. OCLCA 73,631,668. Sturton, Ian, ed. Conway's All the World's Battleships, 1906 to the Present. London, Conway Maritime Press. ISBN A978-0-85177-448-0. OCLCA 246,548,578. Whitley, M.J. Battleships of World War II. Annapolis, Naval Institute Press. ISBN A978-1-55750-184-4A.